here's a little more practice with limiting reactants. If you had a chance to try these, it's kind of nice because you'll know where you made your mistakes, and then you'll have an idea of what you're doing right versus what you're doing wrong. Where sometimes people look at the final answer and they see they have the final answer wrong, and they erase everything, but really they had a lot of things right, and then you'll learn where you're making your mistakes. If you haven't had a chance to try these, I think I would do that. Try them on your own, see how far you can get, then bring back the video and we'll walk through the rest of it. So first thing I need is a balanced equation. Hydrogen sulfide gas can be formed from the reaction between hydrochloric acid and iron 2 sulfide. So it's a double replacement. You can switch the hydrogen and the iron. And one of your products is definitely that hydrogen sulfide gas. The other one is iron chloride, which eventually I'm not going to need to know anything about, but I do need to write the formula so that I can eventually balance the equation. We want to know how many grams of hydrogen sulfide can be formed if 130.5 grams of iron 2 sulfide react with 50 grams of hydrochloric acid. So first thing we need to do is get those grams into moles. We'll divide by the molar mass. And now once you get these numbers in moles, sometimes you can just kind of qualitatively figure out which is limiting and which is excess. I see that it's a 1-to-2 ratio in the balanced equation, meaning I need twice as much HCl. So I look at what I have, and I actually have less hydrochloric acid. I need twice as much. This is maybe like 1.5-ish moles of iron sulfide. I need about 3 moles of HCl, and I don't have anywhere near that. So if I don't have enough, this is my limiting reactant. You don't need a fancy calculation. Now you could calculate the limiting reactant. You pick one reactant, use the mole ratio from the balanced equation to turn it into moles of the other reactant. This is the amount of HCl I would need, which I just estimated to be about 3 moles. And then this is what I have. Yeah, I don't have anywhere near that. So the HCl is limiting. By process of elimination, the iron sulfide is my excess. Cool. So if you don't need to calculate the limiting reactant, you can skip this step. You can just figure it out by inspection, if it's an easy ratio and the moles are easy to work with. Alright, so now I have my limiting reactant, my HCl. I'm going to start my calculation with this 1.371 moles. This is the amount of hydrochloric acid that I have. I do not want to start with this number. That's what I would need, but I don't have that. Essentially, we're never going to use this number. All right, cool. So in the end, I want to go from hydrochloric acid, my limiting reactant, and figure out how much hydrogen sulfide can be produced. It's a 2-to-1 ratio in my balanced equation. If you start with this moles of HCl, you can use that ratio right away. Cancel what you have. I have my hydrochloric acid. It's already in moles. Moles and moles are gone. I can switch it to moles of what I want. And then often we'll turn it back into grams. So cancel moles of hydrogen sulfide. We want grams up on top. We'll multiply by any numbers on the top. We'll divide by anything on the bottom. I left 4 sig figs because the original numbers had 4. A little over 23 grams. Not bad, right? 23.37 grams. And we've answered the first part of this. How many grams of hydrogen sulfide can be formed? Now often they'll ask me about the excess. How many grams of the excess reactant will be consumed? Consumed means like used, reacted. So again, we start with our limiting reactant. All stoichiometry starts with the limiting reactant. But this time we'll cancel the limiting reactant and we'll turn it to the excess. It's a 1:2 ratio between the hydrochloric and the excess iron sulfide. And then we'll bring it back to grams. Cancel moles, we want grams. So when we plug it in our calculator, we'll react about 60 grams of iron sulfide. That's the amount consumed, used, reacted. Then to figure out the amount left over, all we have to do is subtract. We originally had 130.5 grams given in the original problem. We're only going to use about 60 grams, so we'll have a little over 70 excess. Now technically, when you subtract, we're supposed to go with the lower number of decimal spots, so maybe about 70.2 grams. If you can walk through these typical limiting reactant, excess reactant problems, you'll notice some trends and patterns. They all kind of run the same set of calculations. You'll have different numbers, different balanced equations, but you're kind of always doing the same thing. It's a process. And you have to understand what all the numbers mean. It's not like in math where the final answer is just some numerical value. Now I have to know, what does this mean? Well, that's what I have. This is what I need. This is what's left over. So it is essential that we label all numbers when we're doing stoichiometry. There's another one in here if you had a chance to look at this bad boy. And if not, pause it. Push pause on the video, try it. See how far you can get. If you're stuck, bring it back. But don't get stuck and then erase everything. Because again, you may be on the right track, and maybe you started this right and you just used the wrong number. You picked the wrong limiting reactant. We have iron 3 oxide reacted with carbon monoxide gas to produce elemental iron and carbon dioxide gas. Now we had this equation back in the chemical reaction unit. It's kind of a tricky one to balance. The 2 iron, that's easy. You can only work with even numbers of oxygen, because on the product side, I've got that O2 in carbon dioxide. So whatever I put in front, it's only going to give me even numbers of oxygens. So originally 4 oxygen doesn't work. And so try 6. If you put that 3 in front of carbon monoxide, you'll get the 3 carbon, which you can get 3 carbon on the product side. And you do get 6 oxygen on both sides then. 3 from the iron oxide, 3 from the carbon monoxide. And then on the product side, you've got 6, all coming from carbon dioxide. All right, so first step, balanced equation. Next, we're going to have grams of each reactant. And they're going to ask me how much product can be formed. The amount of product is dependent on the limiting reactant. So we got to get those grams into moles. Grams of iron 3 oxide and grams of carbon monoxide. Awesome. So again, this isn't a crazy ratio. It's a 1:3 ratio. I need more carbon monoxide. I need 3 times as much. So if I just do a quick comparison, here's my iron oxide. I need 3 times as much carbon monoxide. So you could just estimate, I don't know, like 3.3 something. I definitely don't have that. I do have a little more, but I don't have 3 times as much. So if I don't have enough, I found the limiting reactant. Which again, you can calculate if you want to, but often if it's like a 1:2, 1:3 ratio, you don't have to show the work. On a test or quiz, it'll say justify your answer. You could just write a sentence and say, I need about 3 times as much carbon monoxide, and I'm not going to have that. So carbon monoxide will run out first. That's my limiting. And that's essentially what we did, but originally I just kind of estimated in my head about 3.3 moles carbon monoxide. Well, if you want to calculate it, you pick one reactant, turn it into moles of the other, and it'll give you the exact amount that you need. I estimated 3.3 something. Yeah, 3.38. And I don't have that. So I found the limiting. If you would do this calculation to see what you need, you compare it to what you have. And if you have more, then you found the excess. And by process of elimination, the other one is limiting. Alright, so we got the limiting reactant, the carbon monoxide. In the end, we want to know how many grams of iron can be produced. So we're going to go from our limiting to our product. A 3-to-2 ratio, which, since you have this in moles right away, and again, you have to use the moles that you actually have, not this guy, we don't really have that. You can use the ratio in the balanced equation right away. We have moles of carbon monoxide. We want to cancel moles. We'll turn it into moles of iron with that 2-to-3 ratio. Then we'll bring it back to grams by multiplying by the molar mass off the periodic table. Whenever you use that periodic table mass, it will always be opposite 1 mole. We already used the 2. We took care of the fact that, yes, there are 2 moles of iron formed. We're already multiplying by 2. So we should get a little over 52 grams of iron. And again, I used 4 sig figs just because the original had 4. Awesome. And if at any point you need to pause this, oh, that's where I went wrong, pause it so you can fix it on your copy. And then at the end, we want to know how many grams of the excess reactant will be consumed or used or reacted. So we're always starting our stoichiometry with the limiting reactant. But this time we'll turn it into the excess. So I'll cancel moles of carbon monoxide, switch it to the iron oxide, my excess reactant. We'll use that ratio, 1-to-3, and then we'll cancel moles and bring it back to grams. So we're going to use about 75 grams of iron oxide. But originally in the problem, we had 180 grams. So we're using less than half of the original sample. To figure out the amount left over, all we need to do is subtract. What you have is originally given to you in the problem, and we'll subtract the amount that gets consumed, reacted, used up, and the difference is what's in excess. It's left over, it's unreacted in the exact same form that we originally had.